Alright, in this lesson we will continue practicing our normal probability calculations with the normal curve and the z-score table and all of that. We'll do both kinds that we've learned in the previous two videos. Alright, just one more day of practice. Nothing new, I don't think. Please do not watch this video with a pencil in your hand, copying down what you see. Don't skip ahead to the end and copy down all the calculations that you see. You will not know how to do it yourself when it's time for the test. So, if you're stuck, watch the video, learn how to do it, and then pick up your pencil and go back and do it your own self. Don't be lazy. Here we go. An important measure of the performance of a locomotive is its adhesion. Okay, locomotive. We're talking about a train. Adhesion. This is the locomotive pulling force as a multiple of weight. The adhesion of one 4,400 horsepower diesel locomotive varies in actual use according to a normal distribution. Bottom line, the mean is 0.37 and the standard deviation is 0.04. What proportion of adhesions measured in use are lower than 0.35? In this corner, you draw yourself a normal distribution, bell curve, some call it. It's a little lopsided, whatever, I'm not fixing it. Drop your mean down the middle, so that's 0.37. Now, if we want to know what proportion of adhesions measured in use are lower than 0.35, well, 0.35 will be to the left. So for starters, okay, there's let's call this our 0.35. And if I want to know what proportion is lower than 0.35, that's going to be to the left of 0.35 in this image. So we will shade the left. Okay, so we're going to find this percentage, this proportion. Okay, meanwhile, we will make an identical z-score graph. Okay, so alright, man, my graphs are getting worse and worse. Anyway, the middle here is always 0 on a z-score graph. And yeah, we're still going to have our number here to the left. We don't know what it is, but we're going to find out in a little while. So just like before, we're looking at the proportion that is less than that value. So these graphs are the same. You must label your graphs, please. This graph we will label z-score. And this graph, we don't have actual units that were given, but they told us that we're talking about force. So let's at least just write down force. Okie dokie. Now, how do we find this proportion, this percentage? Well, this is what we do. First, we need to find the z-score. So we can do that by using the following formula. We know that z-score is equal to the data value minus the mean divided by the standard deviation. So we can calculate the z-score this way. So the z-score will equal 0.35 minus the mean of 0.37 divided by the standard deviation, which was 0.04. Okay, put that in your calculator. That gives me negative 0.5. Okay, great. So that is my z-score. Let's go ahead and put that on our z-score picture. So this is negative 0.5. Did I get that right? Yeah. That means this is half of a standard deviation to the left. Probably should have put a little bit closer. Alright, no worries though. So that puts us one step closer to finding this percentage, this proportion. Okay, so the next move is to turn our attention towards the z-score table. But first we're going to write our symbols. So this proportion that we're looking for, we will write as a probability. So we're looking for the probability that an x value is less than the z-score of negative 0.5. Okay, that's what we're looking for. Now we have to be very careful. Sometimes we have to do like 1 minus the table value, and sometimes we can just use the value straight off the table, just the way it is. Is this one of the cases where I need to do 1 minus the value, or can I just use the value that I find? I can just use the value that I find. The values on the z-score table are always values that are less than the z value, always to the left. So if I want the left, then I can use the values. If I ever needed the values to the right, then I would need to do 1 minus these. But anyway, I can just use them. So let's look for this z-score on the chart. We're looking for negative 0.5. Okay, so I need to be on the negative side. Well, there's negative 0.5 is right there. Bam! I mean, look at it. It's beautiful. So that's exact, actually. So negative 0.5. So that corresponds to this value right here. So that is 0.3085. Point 3085. Okay, and as a percent, that would be 30.85%. Okay, let's go ahead and record that on our picture here. So this red part of the graph here is 30.85% of the data. I don't know why that seems off to me, but it must be correct. So there we go. So now let's put that over here also. So 30.85%. All right, that's this red stuff. Now it's time for the last box, which is where we put our summary sentence. Alright, so join me in writing the summary sentence. Let's look back at the question one more time, and let's reword the question in our answer. What proportion of adhesions measured in use are lower than 0.35? Okay, the proportion of adhesions that are lower than 0.35 is 30.85%. And there you go. Alright, so that's what problem number 1 should look like. Alright, let us move on to problem number 2. What proportion of adhesions are between 0.4 and 0.5? Okay, here we go again. Start by making your normal curve. Okay, you must label it mandatory. Alright, the mean is not a changing, so the mean is still 0.37. Okay, let's see. What proportion of adhesions are between 0.40 and 0.50? Both of those are to the right of this. Okay, so here's 0.40, say. Hold on, I didn't like that one. Okay, so let's say this is 0.40 and this is 0.50. Okay, and if we want to know the proportion that's between these two values, then it's this shaded area that we are looking for. Okay, let's set up the same picture in a z-square form. Okay, the middle z-square is always 0. Okay, and I'm looking for two values over here that I don't know what they are yet. Okay, and we'll be doing the area in between. This is a z-score picture. Okay, so we're looking for these values. I will call them z1 and z2. That looks like zz. Okay, z1 and z2, my friends. Okay, time to find them. Now, let's start by finding z1. Alright, of course z1 corresponds with the x value of 0.40, and 0.50 corresponds with the z value of z2. So let's find z1. So z1 is going to equal the x value of 0.40 minus the mean of 0.37 divided by the standard deviation of 0.04. Okay, so that is going to give me that's going to give me z1 in the calculator now. Okay, so that is 0.75. Okay, that's great, fantastic. Let's go ahead and find z2. I'm going to try to squeeze it in here. z2 should equal this value of 0.50 minus 0.37 divided by 0.04. So z2, again to the calculator, so z2 is 3.25. So there you go. I have z1 and I have z2. Let's go ahead and put both of these values on the z-score picture. So z1 is 0.75. Okay, and z2 was 3.25. Okay, please remember that this means that this value is a little less than 1 standard deviation above the mean, while this value is a little more than 3 standard deviations above the mean. Okay, anyway, we need to find this proportion, this percentage in between. So let's keep going. Alright, to do that, we are going to need to go to the table. Okay, let's see. So let's go to the z-score table, and we will look at these two z-scores now. Okay, before we go to the table though, let's write down the symbolism. This is very important and you may not skip it. If we want the probability or proportion that's in between these two values, I'm going to do this. Starting with the lower value always, I'm looking for the probability that x is between these two z values. So the way I do that is I write 0.75, dispense with the zeros for a minute, 0.75 is less than x, which is less than 3.25. Okay, that's how you write your symbolism. Always least to greatest, so these will always be less than signs. So when I find these numbers, I'm going to have to subtract. Alright, that's how you find the proportion between two values. You find those percentages and you subtract the bigger one minus the smaller one. So let's start with the 3.25, the bigger one. Okay, 3.25 okay is definitely a positive value, so I'm gonna have to get to that side of the table. Okay, let me delete this yellowness. Okay, so 3.25 starts with 3.2. Okay, now I just need to go over to the column that represents the 5, 3.25. So this is column 0, 1, 2, 3, 4, 5. Wow, it's weird that these are all the same. Anyway, this is the number we want, 0.9994. So we're going to do 0.9994 minus the smaller one. So 0.75, let's see if we can find that. Okay, 0.75. Okay, so there's 0.7. And this is 0, 1, 2, 3, 4, 5. Well, I guess I could have looked right up there. So this is the value that we want. So 0.7734. 0.7734. Okay. So let's see what that gives us. I'm just going to punch that into the calculator. It gave me 0.226. Okay, which as a percentage, moving it twice, would be 22.6%. Okay, that means the proportion in between these values is that 22.6%. So let's put that in the picture, 22.6%. It also belongs in this picture. Okay, 22.6% is right in there. Okay, now let us write our closing sentence. Alright, so 22.6% of the adhesions are between are between 0.40 and 0.50. And there you go. Okay, number 3. What's up, number 3? What proportion of adhesions measured are higher than 0.40? Okay, so you draw your normal curve. like you do. You drop your mean. Your mean is 0.37. You label it force. What proportion of adhesions measured are higher than 0.40? So 0.40 is higher than this, so we'll put it over here somewhere. And if we want the adhesions that are higher than this, then I'm going to shade to the right to indicate that. Okay. So we are looking for this percentage right here. Oh, and it said higher than 0.40, so we can write that down. So this is 0.40 right there. While we're at it, let's go ahead and make our z-score picture as well. So draw your bell curve thingy, z-score of 0. Okay. Alright, very important. You must label this z-scores. Alright, if you don't label it, you will lose a couple points. So I don't know this z-score yet, but by golly, I'm going to find it. In fact, I'm going to find that z-score right now, because here's where I do my calculations. And I know that z is going to equal the value, so 0.40 minus the mean, which is 0.37, divided by the standard deviation, which was 0.04. Okay, just put that in your calculator. That is 0.75. And yes, I know that we calculated this same value before when we did this a minute ago, but just in case anybody just skipped directly to this problem, I just wanted to go ahead and show it. So there you go. So we have our z value of 0.75. So let's go ahead and include that on our z-score picture now that we actually don't have to guess what it is anymore. It is 0.75. Now we shall use that z-score to find this proportion. Okay, so we are looking for the percentage of x values that are greater than 0.75. Alright, greater than this z-score. Okay. Question. Am I allowed to just use the values that I find off the chart, or do I need to do 1 minus the values from the chart? This is the situation where I need to do 1 minus the value. Because look, this is to the right, it's greater than the z value. I've tried to emphasize to you that this chart is only giving us percentages to the left. It's always to the left. So if I actually want the percentage to the right, I need to take what I get from the table and subtract it from 1, alright? Because the table is going to really give us this white area. Alright, the red area is going to be 1 minus this stuff. Okay, so it's going to be 1 minus whatever I get off the table. So, to the table, 0.75 z-score. So, wait, well, it's already highlighted, I guess, because we did the same value before. So, 0.75, okay, I'm getting 0.7734. So, 0.7734. Okay, but because it's to the right, I have to do 1 minus that value. So in the calculator, 1 minus 0.7734, that gives me 0.2266. which is 22.66%. So that is what I needed. Let's go ahead and record that on the picture. So this red stuff here is 22.66%. Same with this over here. This is 22.66% of the data. Okay, that's what we wanted. So let's go ahead and write our summary sentence statement and stuff. Okay, 22.66% of the adhesions are greater than 0.40. And there you go. Alright, let us shuffle on down to problem number 4. Alright. Now, these problems on the back are the other kind. Alright, so far, on all these questions, I've been asking you for the proportion or the percent. So, on problem number 1, we found the answer was 30.85%. We were looking for 22.6%. We came up with 22.66%. Okay. Now, and we were given these values. We were given the x values, the data values. For these problems on the back, they're backwards. These are the ones where we're given the percent, and we're asked for what values lead to this percent. All right. See, we're given the percent. What measures give us this percent? We're given 15%. What measures make the 15%? So these are the ones that are backwards, like we learned in the last video, the day 9 video. Okay, so we're bringing it all together in one monster video. Got carried away there. Okay. Well, we shall start off the same nevertheless. We will start off making our normal curve, like we always do. Okay, and we are still dealing with the same mean, which I keep forgetting, 0.37. So 0.37. We want to find out what measures make up the lowest 10%. Okay, the lowest 10% will be down on the left end. Okay, so just put it down here somewhere. Okay, so this will represent our lowest 10%. So we can go ahead and mark this with 10%. There you go. We must label the graph overall. Normally we would have units, but we don't have units, so we'll just say force. Let's make the same picture in a z-score. Okay, by the way, so we are looking for this x value. That's our goal. Alright, so over here, same thing. Okay, there's my normal curve. Okay, the mean on a z-score picture is always 0. You must label it z-scores. If you don't, you will lose a few points. We still want that bottom 10%. Okay, so the lowest 10% will be over here, and we will label it as 10%. And this is a z-score, so I'm just going to call this z. And this is what we're actually going to try to find first. Okay, and here's how you do it. When they give you the percent, you're going to start off with that percent. You got to be careful. Sometimes we can use the percent that we're given. And sometimes we have to use the other percent. Like, this is 10%. That means over here is 90%. Do I use the 10% or do I use the 90%? I use the 10%. If we want to be able to use this table, and we do, like I've said many times now, this table is only for values, percentages to the left of the z-score. It's got to be the left side. But this is the left side, so we can just stick with this. Alright, if it were the right side, then I would use the white area. I mean, just bottom line, you have to use the left side no matter what. That's all there is to it. Just use the left side no matter which side you're shading. Anyway, I'm getting carried away over here. So 10%, let's just start with that. So 10%, this chart is all about decimals, so we have to convert to decimal form, move the decimal to the left. So that will be 0.10. Alright, these all have 4 decimal places, so let me just add a couple zeros on, so 0.1000. And now we're going to look for this value on this chart. If we can't find it, we'll just close as we can. So 0.1000, if you will. You see it's on the left, so you know this is going to be a negative z-score. So let's just jump to the negative side for sure. Okay, so we're looking for 0.100. So I see 0.1s, 0.9s, okay, 0.9, 0.1. Okay, so I'm looking at this value and this value. Okay, 0.1000 is somewhere in between these two. This is 3 10,000ths, but it's 3 away from 0.1000, and this is like 15 away. So the 0.1003 is closest, so I'm going to use that one. Get rid of these distractors here. Okay, so from this, well, first let me write that down, 0.1003. So 0.1003 is closest. Okay, so this is going to give me my z-score. So if I look to the left, I see negative 1.2. Negative 1.2 what, you say? Well, then I look up. Okay, 8. So it's negative 1.28. Alright, so that's my z-score. So this gives us a z-score of negative 1.28. Alright, we're halfway there. We just found the z-score. So let's put it on the z-score picture. So this is negative 1.28. By the way, a z-score of negative 1.28. Alright, remember, a z-score is how many standard deviations away from the mean you are. Okay, so the mean is always right here. So negative 1.28 would be over here somewhere. Okay, because this is negative 1, so negative 1.28 would be a little bit to the left of negative 1. Okay, so I'm just saying. Anyway, what else do you want from me? What do you want? Oh yeah, we have to find x now. So that's what we're going to do. So we have our z-score. So we're going to use the fact that z is equal to x minus the mean divided by the standard deviation. Okay, so that means the z is negative 1.28. So negative 1.28 is equal to the x value here minus the mean, which is 0.37, divided by the standard deviation, which I believe was 0.04. Yeah, look at that. okay, divided by 0.04. So I need to just solve this little equation right here for x. I would multiply both sides by 0.04. Okay, that way these cancel out. Now let's see, 0.04 times negative 1.28 is negative 0.0512, and that's equal to x minus 0.37. So got to get x by itself, so let's go ahead and add 0.37 to both sides. Okay, so plus 0.37. Okay, that is giving me that's giving me 0.3188. Okay, alright, I mean, this is just a value, okay, so not a percentage or anything like that. This is just how they measure adhesion force. So I am just going to go ahead and round this to 2 decimal places like the mean is. So round it to 2 decimal places, this would be 0.32, okay, rounding up. Okay, so this x value over here, we just found it. It is 0.32. Alright, please don't try to turn that into a percent just because it's a decimal. Okay, we already have a percent. Okay, so this is 0.32. And that is what we were looking for. So it's time to answer the question now. So let's see. What adhesion measures make up the lowest 10%? Well, the lowest 10% of adhesion measures are below what did I say, 0.32. And there it is, a thing of beauty. Alright, and there's the whole problem at a distance. Isn't it lovely? Alright, let's go ahead and crack number 5. Between what adhesion measures do the middle 50% fall? Okay, sometimes these are weird when we start doing the middle percentage. Okay, I hope I don't blow your mind. Alright, so draw your normal curve, and once again we will just label this force. Okay, now what do they want? Between what adhesion measures do the middle 50% fall? Okay, so the middle 50%. So you know, just throw up some lines. Okay, so the middle, so it should be the same on both sides, right? As best as you can. So we don't know what these values are, so I'm going to call this x1 and x2 because those are the values between what measures. These are the measures we're looking for. Okay, but whatever they are, let's go ahead and shade this in because this represents the middle 50%. Okay, shade it in. The mean, we know the mean, it was 0.37. Okay, I'm going to include that in the picture, 0.37. Okay, so this is the middle 50%, so let's label that up. Okay, now let's go ahead and create the same picture for the z-score situation. Okay, so your z-score picture should look exactly the same, but instead of x's, there are z's. Oh, this shouldn't be 0.37 anymore. Z-scores, the middle z-score is always 0, because the mean z-score is always 0. Okay, and you must include the label of z-scores. Anyway, our goal is to find these x values. How will we do it? Well, the key is first we have to figure out what these z-scores are. Okay, and to figure out what the z-scores are, we need the percentage to the left. Remember, if we want to use these values, and we do, we have to use the percentage of the picture that's to the left of the z-score. So let's start with z-score number 1. What percentage of the picture is to the left of it? Okay, so I'm talking about this right here. Okay, do you understand? All right, everything that I just highlighted in yellow, that is to the left. So that is what I want if I'm going to find z1. Can you help me figure out what this number is, what percentage it is? Okay, hopefully you're actually thinking about it. Look, we have the 50%, right? What does that leave for the rest of the picture? Okay, yeah, if this is 50%, then that leaves 50% for the rest. Okay, that means the left and the right. So I have to split the remaining 50% in half. So that means this will be 25% over here, and this will be 25% over here. So this graph breaks down as 25%, 50%, 25%. But if I want to find z-score number 1, I need to use the 25% because that's the part of the graph that's to the left of it. Okay, so let's use the 25% to find z1. Okay. Okay, so let's find, so 25%. 25% as a decimal is 0.25. I'm trying to use the table, so I'm going to make it 4 digits, so 0.2500. Okay, let's look for this, or as close to it as we can get. Okay, now this 25%, this z1 that I'm looking for, it's on the left. So you know it's going to be negative. So let's look on the negative side for 0.2500. Okay, so here we're on the negative side. I see 0.2, 0.24, 0.27. Okay. All right, so it's going to be between these two values. All right, remember I'm looking for 0.2500. All right, 0.2500. Okay, well this is 14 away from it, but this is, let's see, 85 would have been 15, so this is like 17 away. So this one, the 0.2514 is a little closer. Whoa, what's that? I don't want that. Okay, I don't know what I'm doing suddenly. Okay, 0.2514 is the closest. So 0.2514 is closest. Real quick, some kids are not actually comfortable with what I just did. Looking at these two values and deciding which one of these is actually closer to 0.2500. So just for once, let me break down a concrete way of telling which one of these is closer. I'm hoping that for most of you it's sort of common sense. Oh, this is 14 away. This is 14 above. This is 15. This is 17 below. But many of you don't understand a word that I'm saying when I say that. So let me break it down for you. We are trying to get as close as we can to 0.2500. Okay. On the one hand, okay, on the above side, we have 0.2514. All right, that's higher than this. On the below side, we have 0.2483. Okay, 0.2483. Okay, if you really want to know which one of these is closest, whether you do it mentally or not, you are subtracting. Okay, so for example, looking at this one. Okay, if I try to find the difference between these, all right, what I'm talking about is doing 0.2514 minus 0.2500. Okay, check it out. 0.2514 minus 0.2500. That tells me that these, I don't know if you can really see it, these are 14 apart, if you will, 0.0014. Okay, so that is 0.0014. Okay, that's how far apart they are. Now if I do the same thing with this one, okay, so I'm just going to keep doing the bigger one minus the smaller one. So in this case, that would be 0.2500 minus 0.2483. Alright, if I subtract these, basically, 2483. Okay, that is 0.0017. So 0.0017. Okay, that is the distance apart they are. So 14 is closer than 17. That's why the 0.2514 is the closest, not the 0.2483. So most of you should be able to do this sort of subtraction in your head and go, oh, look, this one's a little bit closer. But if you can't tell, subtract. Just take your calculator, subtract both of them from the number you're shooting for. Whichever one gives you the smallest number, ignore any negative signs, but whichever one gives you the smallest number, that's the one you use. Okay, I'm not going to explain that probably ever again unless you specifically ask me, but I figured I should probably break it down once. You're welcome, all two of you. Anyway, this is closest. So back to business. Let's find out what z-score this gives me. Alright, remember, alright, we're doing this lower, we're doing the 25%. The 25% is left of z1. So we are finding z1 right now. Okay, so we had decided that this was the number that we were going to use. So look to the left. Okay, this is going to give us the z value. So it's negative 0.6. Wait a minute, negative 0.6 what? Look above. Look above. Oh, I see. Negative 0.67. Feel me? Okay. So this is negative 0.67. Okay, that is Z1. We just found it. So let's go ahead and put Z1 in its place of honor. Okay, so this is negative 0.67. Okay, by the way, just for fun, negative 0.67, that's less than 1 standard deviation over. Okay, so that would be like maybe here somewhere. Alright, this would be negative 0.67. Anywhoozle, back to bidney. Now, look, guys, maybe you can guess the other z-score. I don't need to do any more calculations because they said the middle 50%. This is in the middle. There is symmetry here. So if this is negative 0.67, guess what this is? Yeah, positive 0.67. So I don't need to do the percentages again. So this will be positive 0.67. If I was going to do it over again, though, my question to you would be, which percent would I use to find this z value? Like I used the 25% before? Well, just remember, if I want to find this z value, like imagine I didn't already know it. So imagine that we were going to try to find z2 right now. Remember, the percent you use is everything to the left of the z value. So this is what I'm talking about. Everything from the z value over. Okay, so I'm talking about this part of the picture. Okay, everything I just highlighted in yellow is to the left of this z value. So could you tell me what percent this is that I just put in yellow just now? What percent is all this? It is 75% because it's the 25% and the 50% put together. Okay, so if I was going to find this z-score by hand, what I would have used, try that again. What I would have used was 75%. Okay, because 75% is all of this from here all the way to here is 75%. Okay, and that's to the left. So I would have gone 75% equals 0.750 equals 0.7500, and I would have looked for the closest thing. Okay, would have been on the positive side. And okay, what did I say I was looking for? I'm looking for 0.7500. Okay, so oh look, there's 0.7517. Alright, this is 0.7486. This one's closer. This is z-score 0.67. Okay, oh wait, I forgot to say 0.7486 is closest. So 0.7486 is closest. And that gives us a z2 of positive 0.67. Okay, but that's definitely the long way. You do not have to show that when you know the symmetry is in full effect. Use it. Okay, we knew it was going to be 0.67, but I went ahead and showed it just for, you know, giggles. Okay, that is beautimous. Anyway, now that we have the z-scores, we can find the x values. So let's do that now. I think I'll do it in purple. Alright, the x values are really what we need. So I'm just going to split this work area in half. Okay, let's find x1. We will get x1 from z1. Okay, so using the formula, I'm just going to remind you off to the side. The formula is z is equal to the x value minus the mean divided by the standard deviation. So I'm going to use that twice. Okay, so this first z value is negative 0.67. So what I have is negative 0.67 is equal to x1. Okay, sorry, minus the mean, which is 0.37, divided by the standard deviation, which is 0.04. Multiply both sides by 0.04. Okay, so these cancel out. Okay, let's see. 0.04 times negative 0.67 is negative 0.0268. So that equals x1 minus 0.37. Alright, so we need to add 0.37 to both sides. So let's see, plus 0.37. Alright, I'm just going to squeeze it. I'll squeeze it in. Okay, so that's giving me 0.3432. Okay, that is x1, people, 0.3432. Okay, I'm going to round that down to 0.34. So I will just put this down here. So basically 0.34 is x1. So that is one of the main things we were looking for. Okay, so we just found x1 and it was 0.34. Okay, now similarly we will find x2. We will find x2 using z2. Okay, so 0.67 is equal to x2 minus the mean, 0.37, divided by the standard deviation of 0.04. Once again, multiply both sides by 0.04. So these will cancel. So 0.04 times 0.67. Okay, so that's giving me 0.0268. And that is x2 minus 0.37. So it's time to add 0.37 to both sides. So let's see, plus 0.37. That gives me 0.3968 equals x2. Alright, so basically that means x2 is 0.40. I'm going to round this up because of the 6. So this rounds up to 40, from 39 to 40. Okay, so that's another key value. So x2 turns out to be 0.40. Da-da-da-da. So those are the values we were looking for, 0.34 and 0.40. Okay, because of my extra explanations, alright, that problem took a long time to do, but it's really because I was talking so much. Okay, extra knowledge. So time for the summary sentence. Between what adhesion measures do the middle 50% fall? I'm going to turn that back around. So the middle 50% of adhesion measures fall between, and it was 0.34 and 0.40. And there it is. Okay, and there's how it all looked from a distance, man. Check it out. Okay, anyways, last problem, number 6. This video is an hour, so hoping nobody had to watch the whole thing. Let's see, what adhesion measures make up the highest 15%? Let's go ahead and draw the distribution. Okay, so we have our curve here, our mean, label it as force. Now we want the highest 15%. So the highest 15% is going to be up on this end, okay, somewhere up in this area. So just go ahead and throw it up and shade it. So this will represent our highest 15%. Now let's duplicate this as a z-score picture. Alright, so here's the z-score side of things. You must label this, by the way. Now we don't know what this value is, so when we don't know, we will just call it z. There's just the one of them. And we don't know this either. I will call this x. Okay, so we are looking for x. That's our goal. But we always have to find z first. So I need a percentage. Am I going to use the 15%? The answer is no. I'm not going to use the 15% because to be able to use this chart, which is what I need, the chart is only going to deal with the left side of the z value. So regardless of which part I'm shading and all that kind of stuff, you have to use the left part. So the left part, of course, is the left part is this aspect. Okay, this is the left. Alright, everything I just shaded in yellow, that's the left, that's the percentage that I need. What percentage is that? Okay, yeah, I'm gonna go with 85%. Okay, so this over here is 85%. How did I get that? I did 100 minus 15. Okay, if we add them up, 85 plus 15, that's 100. So I got to add up to 100. So regardless that the red is the highest 15%, you use the left part regardless when you go for this chart and stuff. So we will use the 85% to find the z-score. So I think I'll just stick to the green. So 85% is equal to 0.85, which I will think of as 0.8500. Now let's find it the closest we can. Okay, this is on the right side, so I know it will be positive. So be on the positive side and look for 0.8500. So I got 81, 82, 84. Here's 85 right here. Okay, and that's the next thing. So this is 8 above, this is 15 below. This one's closer. So this is closer. So z-score wise, that means I'm going to use this and this together. So this is 1.04. 1.04. Okay, so that's z, people. Oh, I forgot to say what was the closest. So 0.8508 is closest. You must write this down. Okay, 0.85. You made me forget what it was. All right, 0.8508 is closest. So that means z equals what was it? 1.04. Okay, so I have my z value. So let's go ahead and put that in the picture. .04. By the way, 1.04 would be pretty much right here. Okay, because this is the mean. This is a standard deviation of 1, and 1.04 is so close that you can't tell the difference. Anyway, I'm getting off task now. So I found the z-score. So that enables me to now find the x value, which is what I really wanted the whole time. Okay, so the x value. Again, I'm using this formula that says z is equal to the x value minus the mean divided by the standard deviation. Okay, the z value is 1.04, so that means 1.04 is equal to this unknown x value minus the mean, which is 0.37, divided by the standard deviation, which is 0.04. I'm going to solve this for x and be done. So I will multiply both sides by 0.04. That way these will cancel out. Okay, so let's see, 0.04 times 1.04. 0.04 times 1.04. That gives me 0.0416. And that equals x minus 0.37. Trying to get x by itself, so I will do plus 0.37 on both sides. Okay. Yeah, okay, so plus 0.37. I'll do that now. So that's going to give me 0.4116. Okay, and that is equal to x, which is what I was looking for. Alright, so in fact, I'm going to go ahead and put that up in the picture right now. So I found x. X is, oh yeah, let me go ahead and round. So this is like 0.41. Because the next number is a 1, I'm just going to leave it 41. Okay, so okay, I just rounded. So that's what we needed. That's what we were looking for. So let's go ahead and answer the question as a complete sentence in this area right here. First, I will look back at the question, and I will incorporate the question in my answer. So, what adhesion measures make up the highest 15%? Let's see. So I will say the highest 15% of adhesion measures and they are above 0.41. And that is it, my friends.